If you strip down the motor of an electric vehicle, the speakers in your smartphone, and the targeting sensors of a stealth fighter jet, you'll find they all rely on the exact same materials to function. And that shared dependency has created a massive vulnerability hidden deep inside the global supply chain. We call them rare earths, a specific group of 17 metallic elements on the periodic table, known as lanthanides. But that name is actually a geological misunderstanding. Elements like cerium and neodymium are abundant. You can find them in the Earth's crust all over the world. The problem is not digging them out of the ground. The bottleneck is a chemically stubborn process called separation. Because these metals are often found tightly clumped together and bound with radioactive elements, refining them requires dozens, sometimes over 100 distinct purification steps. Every single one of those steps consumes vast amounts of water and energy. To produce just 1 ton of refined rare earths, you have to generate thousands of cubic meters of toxic gas, acidic wastewater, and radioactive residue. Winning the rare earth market was a choice to endure levels of environmental devastation and human cost that most other nations found intolerable. In April 2025, that monopoly was weaponized. In retaliation against U.S. tariffs, the Chinese government announced that exporters would need special state-approved licenses to ship out 7 critical heavy rare earth metals. Without those specific metals, high-temperature permanent magnets cannot be manufactured. Supply chains froze almost overnight. Automakers found themselves rationing components, and tech manufacturers began panic buying whatever inventory remained on the open market. This chart tracks the immediate shock to the system. In May of that year, Chinese exports of rare earth magnets plunged by 74%. Simultaneously, the price of these materials on the European market spiked to 6 times the domestic rate in China. The 2025 restrictions exposed the vulnerability of a fully integrated global supply chain. With one administrative move, Beijing demonstrated that the flow of critical components now depends on a single gatekeeper. To understand how we got here, we have to look back to the 1980s. At that time, the United States was the leader in rare earth production, primarily drawing from the Mountain Pass mine in California. But in the 1990s, Beijing recognized the strategic value of these elements and initiated a deliberate, state-sponsored takeover. Operating under a command economy with heavily subsidized state firms and virtually no environmental oversight, China flooded the global market with cheap processed materials. The West watched its own processing facilities go bankrupt, unable to compete on price. Then, in 1997, the U.S. government approved the sale of MagnaQuench, General Motors' premier permanent magnet division, to a consortium that included Chinese state firms. The vital intellectual property for making the world's strongest magnets was boxed up and moved overseas. Over time, as Beijing began implementing its own domestic environmental standards to clean up its toxic mining regions, they didn't stop production. They simply exported the most hazardous extraction work across their borders into weaker, often war-torn jurisdictions. Today, loosely regulated mining operations pump harsh chemical reagents directly into the mountains of Myanmar. Those toxic leaching pools now supply roughly 57% of China's heavy rare earth imports. The trade-off was entirely voluntary. Western firms prioritized the immediate cost of electronics, leaving Beijing to capture the entire midstream refining sector and the strategic leverage that comes with it. That dominance becomes painfully clear when we look at this map of the global mine-to-magnet supply chain. Pulling raw ore out of the ground in Australia, the US, or Africa means very little, because you can't put a raw rock into an iPhone. It has to be refined. And when we look where that refining happens, the lines converge into a massive bottleneck. China currently controls 91% of global rare earth refining capacity and manufactures 94% of the world's finished permanent magnets. Total control of that processing step is the ultimate weapon. It allows Beijing to implement targeted export licenses, deliberately delaying or denying shipments to specific foreign defense contractors or tech companies without ever declaring a total trade embargo. By controlling the narrowest point of the processing funnel, Beijing effectively dictates the industrial rhythm of high-tech manufacturing across the globe. For the Pentagon, this supply chain reality is an operational nightmare. Radar systems, missile guidance chips, and aviation actuators rely on specialized rare earth alloys. Without them, modern defense systems go blind and ground themselves. The sheer volume of material required is staggering. A single F-35 fighter jet contains over 900 pounds of rare earth components. Scale that up to naval warfare, and a single Virginia-class submarine requires an astonishing 9,200 pounds of these specialized metals to function. And here is the hardest strategic fact. As of right now, there is zero commercial-scale separation of heavy rare earths happening inside the United States. In a war of attrition, Beijing has the capacity to replenish its munitions and build next-generation aircraft faster than Washington. They could do this simply by choking off the very materials the US needs to assemble its own fleet. The 2025 export restrictions triggered a panicked rush of capital to fix the problem. The US Department of Defense stepped in, injecting $400 million into domestic operators like MP Materials to rapidly build separation and magnet manufacturing facilities on American soil. But look at this bar chart to see the reality of the scale disparity. Even when the new US facilities are fully operational, they aim to produce about 1,000 tons of magnets annually. China is currently producing 300,000 tons. Geologically, there are ways to close that gap. Vietnam, for example, sits on an estimated 3.5 million tons of rare earth reserves, yet they currently provide less than 1% of global supply because they lack the technical infrastructure to process it. Standing up those facilities outside of China comes with an unavoidable economic truth. Operating mines and refineries that actually comply with Western environmental regulations and labor standards makes the final product roughly 40 to 80% more expensive. Building a secondary supply chain requires the West to finally pay the premium price for its own sovereignty. In the modern economy, strategic independence is a commodity that is no longer available at a discount.